Yes, sir.
Okay. So students, I have shared two audio lectures with you on this MS Team. Have you gone through those two lectures? I have shared two lectures with you on MS Teams. These are the two videos of our first two lectures. Have you gone through those two lectures or not? Are you listening to me, students, or not?
Yes, sir, we are listening.
Okay, please tell, have you gone through those two lectures or not?
सर एक्चुअली वो हमें शायद ये लगा था कि इस वीक शायद सर यूसुफ की क्लास है तो मे बी आपकी क्लास नेक्स्ट वीक हो तो मे बी कुछ स्टूडेंट्स ने ना देखे होंगे नेक्स्ट वीक तक देख लेंगे.
Okay, so I'm preparing the other lectures as well. Please go through them as you get the time. My request to you, because we haven't taken the classes, so I think you have finished your force method with Dr. Yusuf.
Yes, sir, beams, frames, and trusses we have done.
Now, so that's why I have taken this class as well from him, so that we can finish this slope deflection method as well. So introductory lecture and derivation of slope deflection method. These two lectures I have uploaded on MS Teams. So now the second lecture, which is most important, I think first one, if you go through first one, that has been already being delivered to you by Dr. Yusuf partly, but the second lecture that is important for us, that is regarding the slope deflection method, its derivation. So if you haven't gone through, how many of you have taken this lecture or not? कोई ऐसा जिसने वो सुना हो lecture? Anyone who has listened that lecture? Nobody? बता दें भाई, नहीं भी पढ़ा तो फिर भी बता दें.
नो सर सिर्फ फर्स्ट ही देखा है बस.
अच्छा, चलें फर्स्ट देखा हुआ, सेकंड नहीं सुना आपने. So now if I give you a time, actually this is about 38 minutes. ये जो वीडियो आपके पास है ये तकरीबन 38 minutes की है. So if I give you a time of about 30 minutes, please you can listen right now and then we can discuss it.
Okay, sir.
So please you can take time after 38 minutes. I'll start the lecture after this derivation. So this total video is of 38 minutes. Please you can go through within this lecture time even. Doesn't matter.
Okay, sir.
I'm here online by the way. So meanwhile you can go through that lecture by on the same MS Team you can open and you can listen to that lecture.
Yes, sir.
Yes, sir.
Okay. So this is our equation for slope deflection method. If you see, this is our equation MAB equals to 2EI over L into 2 times theta A plus theta B 3 times delta over L plus fix and moment. So as you have seen this on this recorded lecture, these all actually are the separated effects of individual structures by considering, let's say this was we taken up by considering theta A as a redundant. Then this we considered as that our unknown displacement was theta B over here, and here our unknown displacement was theta delta, and this is actually due to the applied load. So we applied principle of superposition And then we found that this universal relationship to solve any structure by slope deflection method. Now there are two slopes or linear or angular displacement, and one linear displacement is involved within one relationship, and same is for the other one. So these are two end moments on a beam actually. If we have a continuous span beam, this is our, let's say, continuous span beam. So these are two end moments over there. This is one end moment and this is second one end moment over there. So two end moments. If we can find out these two end moments, we can find out the reactions as well. So by simply, this is MAB over here, this is MBA over here. The methodology adopted by Henrik Medrela or G. Many who modified this method actually, they found that if they can find out these end moments, they can drive a relationship. And the sign convention for this method is clockwise moments are positive. These end moments which we are finding out, these internal end moments, the clockwise rotation is positive. And then rotation is also clockwise positive, this rotation theta A. And this theta B also is as positive rotation. Then if the settlement which is happening over there, this is a relative settlement of point B to this point, but if it is rotating this element, in clockwise direction, then again this settlement is positive. So this is our sign convention for this method we are going to follow. So these are all end moments due to applied load, fixed end moments. So this is the fixed end moment due to the point load. So there can be a multiple scenario within a beam actually. If a continuous beam is there, so let's say two ends are fixed. So there can be an option that the load is applied right exactly in the middle. So what will be the end moment due to applied load? So this effect actually we need to find out, and we need to add in our this equation right over here. Is it clear or not, students? This is what I'm just taking the lead to start with our example.
सर उसमें वो जो आप कॉन्जुगेट बीम मेथड के बारे में डिस्कस कर रहे थे सर, वो तो शायद हमने पढ़ा ही नहीं हुआ कॉन्जुगेट बीम मेथड।
मुझे आइडिया था, इसीलिए मैंने उसको वहां पे एलिब्रेट करने की भी कोशिश की है लेक्चर में भी, इफ यू रिमेम्बर।
यस।
तो मैं दोबारा, अगर उसको लेक्चर में आप जाएंगे तो मैंने इसको वहां पे दोबारा एक्सप्लेन करने की भी कोशिश की है डिटेल में। सो व्हाट इट इज एक्चुअली, ये है क्या कॉन्जुगेट बीम मेथड? ये आपके पास ड्राइव होता है फ्रॉम द इंटीग्रेशन ऑफ load actually, it is equals to the shear, if you remember in your mechanics of material. Then whatever is the area of the load diagram, that is the shear actually, isn't it? ऐसी नहीं है कि जो आपकी लोड डायग्राम का एरिया वो आपकी shear, और जो आपकी shear डायग्राम का एरिया है, area of the shear or integration of the shear, that is equals to moment, if you remember these relationships. These two relationships, if you remember. Hello?
Yes sir.
यस सर।
सो कॉन्जुगेट बीम मेथड क्या है जी आपके पास? कॉन्जुगेट बीम मेथड है कि ये आपके पास एक रियल बीम है, इसको आप यूज करते हैं, इसको आप कन्वर्ट करते हैं एक इमेजिनरी बीम में टू फाइंड आउट अननोन स्लोप्स एंड डिफ्लेक्शन. दिस इज द मेथडोलॉजी which is not involving any equations. Just like in your virtual work or unit load method, you have a equation, let's say capital M small m over EI into dx, if you remember this unit load analysis for finding out deflection or rotation. ये आपने की है force method में, I think काफी डिटेल में use to find out deflection or rotation. This is by unit load analysis normally used, but this is another method to find out the deflection or rotation. Now, how you can find? You can say there whatever is the fixed support, there is an imaginary beam. We assume that there is an imaginary beam with respect to the real beam. This is a real beam and this is a conjugate beam actually. Wherever we have a fixity in the real beam, it corresponds to free end in the conjugate beam. It is a free end. So once it is a free end within the beam, so it corresponds to means to that whatever is the moment, whatever is the deflection, or whatever is the deflection within the real beam, whatever is delta over here, whatever is deflection over here, it will be reflecting moment over here. This is the concept behind it. And whatever is the rotation over here, it is reflecting shear as in the conjugate beam. So mean to that, whatever the deflection we see in the real beam, that will be deflected as a moment in the conjugate beam. It means if I can draw a conjugate beam, if I can draw a conjugate beam with the loading, and I can take sum of moment at any point, that means that is corresponding deflection in the real beam. So this is the concept, very simple actually. So you draw a conjugate beam. So the other thing which is very important within the conjugate beam, that is the load diagram. So whatever is the moment diagram, whatever is the moment diagram here, it is actually, it's M over EI is a load diagram in the conjugate beam method. So it means I want to draw a conjugate load diagram of a conjugate beam method. I need to draw a bending moment diagram of real beam. So then simply I can draw the load diagram. Then after drawing this load diagram and these end conditions, I need to only take the moment at any point to find out deflection over here. Sum of moment at any point within the conjugate beam is basically deflection in the real beam. So this is a very simple concept they have used to find out deflection and rotation. So it was supposed to be taught to you in, I think, mechanics of material. If they haven't taught you, maybe you should have discussed in your elementary structure analysis. So, but still, if you haven't covered it, you can keep this concept with you, that the deflection in the real beam is represented by the sum of moment over here, and rotation over here is reflected as shear within the conjugate. Now similarly we define this supports as well. So as we know here, slope is 0, we know shear at this slope is 0, theta is 0, delta is 0. So that means there is no movement, no shear. So same we try to take is the end condition as well. There will be no end condition which is resisting any movement or shear. So that's why we keep it as free end, because it is not resisting any rotation or shear or any movement over here. So this is the concept behind using this methodology actually. But once you draw this, now you see the sum of MA dash. So it means whatever the moment, summation of moment at A dash, it is basically deflection at A. So we know that deflection at A is equals to 0. So that's why we put over here sum of MA dash equals to 0. So once we write down this is one equation. Similarly, we write down the equation second, and we simultaneously solve and we find out a relationship between moment and rotation. This is M is equals to K of theta. If you go back and see your lecture, I've already explained over there. This is M is equals to K of theta. So this is a relationship between moment and rotation with stiffness. This K is basically a stiffness. So if I ask you to give me a relationship between moment and rotation for single degree of freedom structure, these two relationships. अगर आपसे ये पूछा जाए कि आप ये बताएं, you tell the relationship between moment and rotation for a single degree of freedom structure, then gentlemen, you have to give this relationship. You have to find out this relationship. Clear? Is it clear or not? Students, are you there? Students, are you there?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
भाई बता दिया करो, ऐसे लगता है जैसे मैं खुद ही पढ़ी जा रहा हूँ. So it means अगर आपसे पूछा जाए पेपर में कि प्लीज आप बताएं, you tell that what is the relationship between moment and theta, moment and rotation for single degree of freedom structure. So you will drive this expression, you will drive these two relationships. आप ये दो relationship find करेंगे. Another way around, you will be asked that find out the stiffness of the element, find out the stiffness of a member. You find out the stiffness of a member which is having only 1 degree of freedom. So then again you are going to solve this question. So this is how the paper will be actually. So you will not be asked straight away, it will be a small part like structure question over there that you need to find out the stiffness of a single degree of freedom structure. So it means you have to find out these two relationships. Is it clear? Students, is it clear?
Yes, sir.
Now, after these two relationships with us and sign convention and moment, so now we'll go to one more part if we see over here. So in this derivation, if you see, we considered, or this scientists, they have considered a continuous span, internal continuous span, a typical continuous span within the beam. This was a continuous span. Let's say this is going on actually something like this. So this is going on. But if your far end is pin or hinge or roller over here, let's say this is far end is pin or hinge, something like this happens. So if your far end is pin, then this MAB or MBA, let's say this is your MAB. So this is MBA. What will be value of MBA? What will be value of MBA if your this end is, can you?
0, sir.
0. So it means this expression we have driven actually, this one, we can simplify it for the span where our far end is roller or pin. So this we are going to drive actually in the next part of our lecture. Now, if you see over here, so these are our two expressions. This is our slope deflection equation. This is end equation for one end, MAB. This is our second equation, MBA. Now, our far end is pin, then this equation will be modified actually. So we need to modify it because this MBA will be equal to 0. Why it will be 0? Can anybody tell? If our far end is pin or roller. Can anybody tell why this far end is 0? Why this MBA is 0? Then we say that this MBA, आपने ने भी बताया जी कि ये 0 होगा. Why it should be 0? Can anybody explain? Students, can you explain that why this MBA is equals to 0? Students, can you explain? Anybody who can tell जी कोई है ऐसा जो बता सकता हो कि ये रोलर पे या पिन पे मोमेंट 0 क्यों होता है? Guys, are you there?
So जो रेजिस्टेंस नहीं देता तो वो इस वजह से मतलब रिएक्शन ही नहीं होता उसका उधर तो मोमेंट नहीं होता।
बिल्कुल, हाँ जी, बिल्कुल सिंपल ऐसे ही है, यही आंसर था जी। आप इतनी देर पता नहीं क्या साइन कन्वेंशन कवर्ड, गो ओवर देयर, दिस इज इक्वल टू 0. So now if we write down these two equations over here, if we see, write down these two equations. So this is our two equations, and maybe and over here us. Now we see that MBA equals to 0 and fixed end moment due to applied load is also equal to 0, and we solve it simultaneously. We will find out a single equation. We will find out a single equation which is for the other end. This, and let's say this MBA was 0. This is equals to 0, but for this internal moment or at this location on the other side, the equation will be something like this now. So it means whenever our far end is pin, our end span is there, and our far end is pin. So the equation for the internal moment, so rather than writing down two equations for internal moments, we will write down only one equation. हम सिर्फ एक इक्वेशन लिखेंगे, that is m a b equal to 3 times e into k into theta a minus psi plus m a b f. Can anybody explain what this psi is? Chord rotation. So how we define chord rotation? Can anybody tell? What is chord rotation? सुनी moments in case of our far end is pin. If our beam is not within the span, actually it is far end is pin or roller. So it means if our beam or frame, its internal member is there, let's say something like this frame is we have with us. So for this span, we will write down two equations. For this span, we will write down two end moment equations, and for this span, we will write down only one end moment equation, that is over here. This is the purpose of this equation over here. Rather than writing down two equations, we will write down only one equation.
सर स्क्रीन विजिबल नहीं है मुझे, मेरे ख्याल से नहीं विजिबल, शायद पूछ लें बाकियों को।
नहीं सर, विजिबल नहीं हो रही,
नहीं शेयर हो रही। जस्ट वेट, आई विल एक्सप्लेन अभी।
सर नजर तो आ रही है लेकिन स्लाइड शायद स्टक है।
I'll reshare again, don't worry. अब नजर आ रही है जी?
Yes sir.
Now we need to remember that whenever we have far end hinge or pin, this will be our slope deflection equation we are going to apply. Now I'll go back to our example 1 for slope deflection method. This is our first example we are going to solve. So can anybody tell me the steps involved in force method? Can anybody tell me the steps involved in the analysis of force displacement method? By force displacement method, अगर हम किसी भी structure को analyze करना चाहें by force displacement force method, can Anybody tell me step-by-step procedure? ठीक है. Okay. Now, if I tell you step-by-step procedure for force method, in that method, gentlemen, you find out degree of indeterminacy. In very first step, you find out degree of indeterminacy with respect to statics. Whatever is written over here, something like this you find. Then you resolve your structure into primary structures and redundant force structure. Then actually you write down compatibility condition, compatibility equation actually. So here you write down compatibility equation. Then after applying compatibility, you find out unknown deflections and rotations. Once you find out unknown deflections and rotations, you find out flexibility coefficients. So once you find flexibility coefficients, you find out unknown redundant force. You find out reaction. So once you have calculated reaction, you can draw shear force bending moment diagram. This is step-by-step procedure for force method. I'll not go into the detail. You have already well equipped with it. Now, the main difference between displacement method and force method is in force method, we are concerned with the unknown forces. Clear? We are concerned with there, what are the unknown redundant, just as in this example, if I see. So here we have two unknown reactions over here. But in displacement method, students, we are mainly concerned with the unknown displacements or rotations. So let us say I draw a structure with you.
सर
Can anybody?
ये
जी
जो
जी
स्लाइड फिर जरा स्टक हो गई है, स्लाइड शो नहीं हो रही,
फिर नहीं शो हो रही थी.
स्टक हो गई.
अब नजर आ रहा है जी आपको? Is it visible to you or not, guys?
Yes, sir.
Now, if I ask you a structure, I'll redraw it now. Let's say this is a simple two-member frame. If I draw this like this. So what is its degree of indeterminacy? Can anybody tell me? Can anyone tell me what is the degree of indeterminacy? Please tell me your roll number and name, then start explaining it. जी ये जो मैंने स्ट्रक्चर प्लॉट किया अभी, this one. Can anybody tell its degree of indeterminacy with respect to statics?
3.
3, बिल्कुल जी 3. There are 6 unknowns and 6 minus 3 into 1. It will be equal to 3. So this structure is indeterminate by 3 unknown reactions actually. If I enhance this structure and I add one more member over here and there is one more fixity. So what will be its degree of indeterminacy right now? अब इसकी degree of indeterminacy कितनी होगी?
सर अब 6 हो जाएगी.
6 हो जाएगी जी. Now if I add one more member into this, wait, I'll add one more member into it. If I add one more member over here, what is its degree of indeterminacy now?
9.
9. Now it is basically, there are 9 unknown redundant forces now there. isn't it? Unknown reactions are how many? There are 9 reactions for which you need to solve the structure by force method. अगर आप इस स्ट्रक्चर को by force method solve करें तो आपको 9 equations लिखनी होगी and then you have to solve it, isn't it? ऐसे ही है जी. In force method you have to write down or you have to draw 9 primary secondary structures, then you can solve this complex, unknown or indeterminate structure, isn't it? ऐसे ही है.
sir.
Yes,
Now,
sir.
whereas if I ask you what's its degree of kinematic indeterminacy, if I apply a force of this moment I apply here, what is its degree of kinematic indeterminacy? कोई बता सकता है?
Sir, 0.
0. और कोई बताए कि इसकी डिग्री ऑफ काइनेमेटिक इनडिटर्मिनेसी क्या होगी? इसकी चले डिफ्लेक्टेड शेप क्या होगी इस एम फोर्स की वजह से? So this will be its deflected shape, is it? Now if I draw that, there is theta over here, theta over here, there is theta over here, and there is theta over here. So this theta and this theta. So this all basically is having only one unknown. So same structure, if you solve by force method, you need to solve it by 9 equations. You'll write down 9 equations and then you'll solve. And the same structure, if you want to solve by displacement method, you need to solve it for only one unknown. So this is the beauty of displacement method. That's why the researchers, they prefer to use this particular method of analysis. Is it clear or not? You can say the advantage of this displacement method or the understanding of this method. समझ आइए जी कि नहीं?
Yes, sir.
Now I go Now I will go step by step procedure for analysis of this problem by slope deflection method. So in step 1, students, you are going to write down degree of kinematic indeterminacy. You will write down degree of kinematic indeterminacy over there. In step 2, we will find out fixed end moments. So these fixed end moments are actually this MABF, MBAF. So these moments are due to applied loads, and these are the equations which are given to you on the backside page of our Sabler book, or also these are given to you in the slides as well, as I have already explained to you in the. So these fixed end moments are due to the moment due to applied load. So if you see this span over here, so this has a UDL, uniformly distributed load is there. So there will be a fixed end moment on the two ends like this. So we need to find out these fixed end moments due to applied load actually. This is our step 2. In step 3, we will apply slope deflection equation. Slope deflection equation. Then after in step 3, we will apply equilibrium condition. So after applying equilibrium condition, gentlemen, we are going to find out unknown moments or unknown rotations. Let's step 5 will be to find out theta and delta. And then step 6 will be, we'll find out end moments. Then after finding end moments, we'll find out reactions. And once we have reactions, we can draw shear force and bending moment diagram. So these are 7 to 8 steps involved in drawing or solving any problem by slope deflection method. So this classical method of analysis can be, you can say, summarized in these 7 steps. Is it clear or not?
Yes, sir.
So I
सर
have,
ये जो फार्मूला शीट है ये पेपर में भी हमें गिवन होगी, ये जो
जी
आप
जी
कह रहे
जी
हैं कि
जी
आरसी
जी
वगैरह।
बिल्कुल गिवन।
ओके सर।
ये मोमेंट्स जो आपने कैलकुलेट करने हैं ये आपको गिवन होंगे जी, ये क्वेश्चन पेपर। So whereas talking about these steps to solve the displacement method, if you see over here, in displacement method we are applying equilibrium condition, and whereas in force method a while ago we discussed, actually we apply compatibility first जी। force method में हम compatibility apply करते हैं, and in displacement method we apply equilibrium. Is it clear to you or not?
Yes, sir.
So what is the difference between these two methodologies? Now we'll go step by step now. So first method, degree of its, you can say we need to find out its degree of kinematic indeterminacy. So we'll find out that the rotation, deflection here are 0, there will be only 1. So actually this will be something like this. So normally it goes like this, it's deflection shape. So if we see that we are concerned with only theta b. So this theta b is of our concern now. We need to calculate this. So now if we want to calculate theta b, we will find out fixed end moments. How many spans we have over here? कितने spans हैं
Two.
इसमें? 2 spans. So what is your roll number, gentlemen?
86.
86. आपका नाम क्या है जी?
Mubin.
Mubin. Okay. Now we'll find out fixed end moments. So if I redraw this span, मैं इसको redraw करूँ जी. So this is UDL. So the formula sheet given to us, it gives us these two moments, something like this. So this is these two moments. This is given as WL square by 12. And this one is also WL square by 12. Now this is our WL. Now if we apply this WL square over 12 over here and WL square by 12, so you see there is a negative sign in MABF. So why this negative sign? Can anybody tell me why there is negative sign over here?
सर हॉग की वजह से
जी
सर, हॉगिंग की वजह से
नहीं बेटा, एक्चुअली हमने जो साइन कन्वेंशन चूज की है, द साइन कन्वेंशन वी हैव चोजन एक्चुअली दैट द क्लॉकवाइज मोमेंट्स आर पॉजिटिव. If you remember the sign convention we have discussed in the clockwise moments are positive and moments with the clockwise direction are positive. But due to this formula, which is standard formula giving us these two moments, so here one moment is clockwise, other one is counterclockwise. So this one is counterclockwise. So that's why we put it with the negative sign. Is it clear to you or not now?
Yes, sir.
ये समझ आई है कि नेगेटिव क्यों है? क्योंकि ये फार्मूले में हमारे पास काउंटर क्लॉकवाइज है, हमारी साइन कन्वेंशन है कि क्लॉकवाइज मूवमेंट पॉजिटिव होता है, सो इसलिए ये नेगेटिव है जी. सिमिलरली दिस फार एंड इज पिन नाउ, सो विल फाइंड आउट द मूवमेंट एट दिस एंड ओनली. So this one will also be counterclockwise, that's why it is also negative. So this formula 3 over 16 PL is actually from that particular sheet, formula sheet, it will be given to you. So this is our step 2, actually we have solved it to find out fixed end moments. So what is our next step? What is next step for solving the problem, students? The next step is to equation. So we will apply slope deflection equations within these two spans. So we will write down जी आपका क्या रोल नंबर था जो जिसने ये भी बताया slope deflection equation 67. What is your name beta? So now if we see that there are two spans, this is span AB and we will write down equation for span AB and we will write down equation for span BC. So in span AB, there will be two end moment equations. One will be for MAB. One equation for this MAB and one equation for MBA. We will write down. So we'll write down the slope deflection equation 2EI over L into 2 times theta A plus theta B minus 3 psi. So this psi will be actually equal to delta over L. So it means whenever there is a settlement over here, then this psi will come into play. Otherwise it will remain equals to 0 as in this case. अगर ये B support settle करती है, if there is a settlement over here, if it happens, if we have a settlement over here, then we can say that this chord rotation will be there. Otherwise, this chord rotation will never take place. So now if we see that this theta A is equals to 0. Why this theta A is equals to 0? Can anybody tell? आपका 67 है roll number? Okay. So Hamza, so this is a fixed support. Actually rotation at point A is equals to 0. Now why this psi is equals to 0? As there is no settlement at point B and there will be no chord rotation, that's why these both are 0. So our MAB will be equal to 2 by 6 EI theta B minus 120. So this will be our simplified equation for MAB. Similarly, we'll write down the equation for MBA as well, and we'll find out that it is equals to 0.667 EI theta B plus 120. So these two equations are there with us for span AB. Now for span BC, students, we are going to write down equation for MBC. So this MBC will be equal to 3EK into theta B minus psi plus MB. So this will be our simplified equation actually we will use. So this is our simplified equation now we will use for this span now. So third moment actually now is with us. That is MBC equals to 1.5 theta B minus 22.5. So once we have written the equations for each span by applying slope deflection equation, what is our next step?
Equilibrium conditions.
जी बिल्कुल. आपका roll number जी?
Sir, 84.
84. What's your name?
Moin Awais, sir.
Awais.
Moin Awais.
Moin Awais.
Yes, sir.
Moin Awais. Okay. So now we will apply equilibrium. So equilibrium will be applied at this point B now. So we see that once we say that this beam is in equilibrium, it means its every part is satisfying the equilibrium. So if we see that how many equations we have 1, 2, and 3 equations with us, whereas we have unknown MAB, MBA, MBC is unknown to us, theta B is unknown to us. So there are 4 unknowns with us. So it means we need a 4th equation as well to solve the system. So that equation we will bring out by the equilibrium. So if we apply equilibrium at joint B, so the moment over here, that was MBA from the span. And there was over here, there is a moment at this point, that was MBC. So their opposite moment will be transferred to the joint actually, if you see over here. So these both are actually counterclockwise. So this is moment at the span, and once they transfer to the joint, they transfer with the opposite sign convention to keep in the equilibrium. So once we say that this joint is in equilibrium, it means total sum of the moment at this joint should be equal to 0. It means sum of moments at B is equals to 0. So once we say that this moments at B equals to 0, we go and we apply that. What are those two moments? One is MBA, another one is MBC. So we add them up, we put them equals to 0, so we can find out value of theta B. We can find out the value of theta B by simply inputting these two equations, MBC, this equation, and this equation. So these two equations, if we put into this particular equation 4, we can find out value of theta B. So once we find out that theta B is there, we can input this value into this equations 1, 2, 3 over here, and in the last over here. So we can find out end moments, MAB, MBA, MBC. So these end moments are there. So with this, with us MAB, this one MAB, that is equals to minus 135. MBA is equals to 90 kilonewton. So MBC is equals to minus 90. So these end moments are there with us. Once we have end moments, we have applied load with us. Can we find the reactions? If we have end moments, students, if we have end moments, I redraw this span, first span, let's see, and we have a UDL on it, 40 kilonewton meter. There is an end moment over here, that is 40 minus 135. Another one over here, that is 90 actually. So can I find these two reactions?
Yes sir.
How?
सर वो जो ऊपर यूडीएल लग रहा है उसके रिएक्शन अलग से कर लेंगे और दोनों मोमेंट का जो नेट आ रहा है ना उसको एक कपल में अलग से हम जो है वो लगा लेंगे.
Excellent, you did it very fine. आपका रोल नंबर क्या है जी?
सर 103 मोहम्मद उजैर शफीक.
103 Uzair. Uzair, you are CR of the class?
Yes sir.
Okay, shabash. So very fine. So it means if I want to find out to the reactions, I need to find out the reaction due to this applied load, that is 40. So इस applied load की वजह से जो reaction आ रहा है, that is 20 over here. 20 over here. This is due to applied load. Then there is a moment over here, which is actually rotating clockwise, but this net effect we don't know it is clockwise or counterclockwise, we don't know. So what we do actually, we found out a general term in the general equation actually to find out the relationships. So we take down that reaction actually in terms of couple, equivalent couple actually. So here are three possibilities I have given you that you can find out the relationship actually. If you see over here that this is your moment MAB and MBA, so the reaction actually, now you see the total couple, it is trying to rotate the beam in clockwise direction. So we need to have a reaction something like this, isn't it? Its reaction should be like this. But if I go like this, this force will be equal to MAB plus MBA divided by L. And similar to this one is same, is both reactions will same with magnitude. But now this sign convention, I want to keep it in the upward direction. So once I want to keep it in the upward direction, I will put a negative sign with it. So that's why you see over here with the negative sign is there. So it means whatever the position over there, you write down minus MAB plus MB over L, MAB plus MB over L over here. And then you can find out the direction. But if you have applied load P within the middle, then you need to add into it the effect of the load. But if you have a UDL, just as in the previous case, you will find out the reaction of the UDL as well, half. Is it clear or not, students?
Yes, sir, clear.
So it means we can easily find out the reactions once we have moment or end moments over there. So if I go back to the reactions over here in this case, so if you see a reaction at AY, that is equals to WL by 2, that is basically 40 into 6, 40 into 6 divided by 2, this is due to UDL, minus, so this is MAB plus MBA. So our MAB was negative 135, so we put it add with the negative 135 plus 90, so we put it the value, we find out that AY is equals to 127.5. Is it clear or not, students? ये समझ आई है जी कि नहीं? Reaction at
Yes,
AY,
sir.
how we have calculated.
Yes, sir.
Now if we go back to the reaction at B now, there are two reactions actually at B. One reaction due to this span and one reaction due to another span actually. So one force is coming due to this span, another force is coming on one reaction coming to this span. So the total By will be sum of this By1, let's say, and this By2. So this is our By1 and this one is our By2. So here we are donating as left and right. If we go like that, it is Byl or By right actually. So if we put the values, we can find out value of By as 187.5. Similarly, we can find out the reaction Cy as we have done for the point A, and it is minus 15 kilonewton. So once you have the reactions with you, you can easily draw shear force and bending moment diagram. Or you not? Can you or not?
Yes, sir.
Yes, sir.
So now
Yes,
if you
sir.
have the reactions with you, gentlemen, you can easily draw. This one is 127.5, 187.5, and last one is 15. So after keeping this all reactions with you, you can draw its shear force bending moment diagram. Already it's been plotted as well, like for you people. So I'll not go into the details as you already know how to plot the shear force and bending moment diagram. So if I ask you now, what is the step-by-step procedure for the analysis of any beam by slope deflection method? Students, can you tell me? Can you tell me, students, what is the step-by-step procedure for the analysis of any structure by force method? Please tell me your roll number. Tell me your roll number. 67, Hamza. Okay, go ahead. Okay. 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 Very fine. Very fine. Now we'll go to the next part now. We'll go to the next part of our lecture, that is now regarding the frames now. So talking about frames, student, the frames, can you listen to me, students?
Yes, sir.
Now talking about the frames, frames can be of two types. Once we say that frames can be of no sway case, and there is no sideways or lateral displacement, and there is side sway. So what does it mean? It means that let's say we have a frame with us. So if we have a frame and we apply a load on it, there is a load being applied on it. So there is a load in the middle. So if we apply the load and we see that its deflected shape will be something like this. So now if we go by this analogy that there is no lateral movement, this lateral movement is equal to 0. So this frame is no more undergoing any lateral deformation. So then we say that it is a no sway case. There is no sideways movement. So it can be done if the structure is properly restrained. There are three conditions, and the structure is symmetric with respect to geometry and loading. If the structure is symmetric with respect to geometry and loading, then and these three conditions are satisfied, our structure will remain under, or our frame will remain under no sway condition. Is it okay, students, or not? समझ आई जी कि नहीं?
Yes, sir.
So how many conditions are there for a frame to be in a no sway case? We can say that this frame will be under no sway formation. There will be no sway. So it means if the frame is properly restrained and it is symmetric with respect to loading and geometry, if both are available over there, these three conditions are satisfied, we say that the structure will not sway. But if there is a frame over there, let's say we draw one more frame. Sorry for the drawing, actually I'm drawing it with the mouse. So if this structure is being subjected to a load which is lateral load, if I say this one, so then so this lateral deformation, this lateral displacement of the structure, this delta, this lateral deformation of the structure, it is called as side sway. So it will happen once the structure is not properly restrained. If the same structure, if the same frame, if I restrain it in the lateral direction, students, if I restrain it over here, I give a hinge support here. So there will be no deformation in that case. So it means number one is it should be properly restrained. If it is not properly restrained, and if it is unsymmetrical or there is unsymmetrical loading and geometry of the structure is there. If let's say there is one frame, is one edge is like this, another one is like this. So again, we'll see that the structure is going to exhibit lateral displacement. So these things should be very clear to you, that what are the scenarios when structure will go under any lateral deformation. समझ आई है जी कि नहीं? Is it clear, students, or not? Students, are you there?
Yes, sir. Yes, sir. Clear.
Clear. So it means there are three conditions we can say that the frame will exhibit sway or no sway formation. So So if I go to the examples, these are some examples that when the structure will no sway formation, it is again a formation, then their structure will be in no sway frames. Then there are cases where there will be sway will happen. So this is our example for the frames now. So again, within the framed student, if we go back and we find out either it is frame or beam, if it is no sway case, in no sway case, our methodology for the solution remains same. As we are solving the beam, the analysis procedure is same for the frames. So how many members are there within this frame? Can anybody tell me?
3 members.
3 members.
3 members. So if we so we'll go for span AB, span BC, and span CD. So there are 3 spans now. So let's say this is a continuous beam. So I can make it something like this. I can say this is there is a fixity over here. There is a rigid connection over here. I can say that this one is also rigid. And then there is something like this. So if I solve this beam like this, so they will give me almost approximately same results actually, because there is no lateral deformation going on. But instead of this support actually now, here we have a rigid connection. Can anybody tell me what is this rigid connection?
सर जिधर जो है हमारे पास मोमेंट भी होता है.
Basically, it transfers the moments from one end to the another one actually without losing its stiffness or integrity. This is the definition of rigid connection. Let's say it is, if it is 90 degree, it will bend at 90 degrees. So this del D is actually at 90 degree. That we are assuming that our material is not going under non-linear formation. Our material that is under the linear, something like, let's say this is our steel. So we are doing analysis within this region. We haven't done the analysis. We haven't discussed what will happen to the structure once we will be in the non-linear phase. In the formation that where our modulus of one. But coming back to our major point, the steps involved. One is that you find out degree of kinematic indeterminacy. So there is theta B over here, and there is theta C over here. So we are concerned with these two theta. Now, step 1, we will find out fixed moments. We calculated phased on the plane. Then we'll find out step 3, slope deflection equation. So we can write down slope deflection equation for span AB, span BC, and span CD. So these spans, we have written 6 equations now. If you see 2 equations within each span. And for each span, we write down the conditions of equilibrium at sum of moments at B equals to 0 and sum of moments at C equals to 0, and we find out end moments. So this is simple procedure as we have done in the case of beam. So it means you need to remember the steps. You can solve any problem with the slope deflection method. Can anybody explain now steps involved in the displacement method by slope deflection equations? Anyone know me? ये 4 स्टूडेंट्स ही मेरे पास आ रहे हैं जी. आप चारों में से कोई बता दे जी. मुबीन, हमजा, अवैस.
सर सबसे पहले डिग्री ऑफ इंडिटर्मिनेसी पहले निकालेंगे कि कहते हैं कौन सी हमारे पास. मोइन सर, डिग्री ऑफ काइनेमेटिक इंडिटर्मिनेसी निकालेंगे, फिर हम इसके अंदर स्लोप डिफ्लेक्शन एंड कंडीशंस यूज करके मूवमेंट्स और उसके बाद स्लोप डिफ्लेक्शन से हम उसकी इक्वेशंस बन जाएंगी. फिर इक्विलिब्रियम से हम उसके अंदर एम्स की वैल्यू निकाल के थीटा कंप्यूट कर लेंगे और फिर हमारे पास मूवमेंट्स आ जाएंगे एंड बी पे या सी पे हम उस पे ले सकते हैं मूवमेंट्स की वैल्यू निकाल सकते हैं
बिल्कुल जी. So if I go back and if we summarize this, it's very simple method. If you see, this is extremely simple method if we want to apply actually. So method actually that is the analysis of a frame which undergoes a sway case. So what I will do, I will record that lecture for sway case. I will record that lecture of sway case frames and I request you to please go through that lecture. Okay. Okay, students.
Okay, sir.
Okay, sir. Sir, next week वाला lecture आप ही लेंगे या सर यूसुफ
नहीं,
लेंगे?
next time इंशाल्लाह सर यूसुफ आपके साथ क्लास लेंगे.
Okay, sir.
But I request you please you go through that sway case. चूंकि वो एक एग्जांपल रह जाएगी हमारा ये स्लोप डिफ्लेक्शन खत्म हो जाएगा. Got it or not जी? समझ आई है कि नहीं? Students, is it clear to you or not?
Yes, sir.
Is it clear to you or not?
Yes, sir. Clear.
So now there is an assignment for you for the slope deflection method, students. You need to solve it. Assignment is very simple. It's not very hard for you. So you just need you go to the R.C. Hibbeler book. It's chapter 11 in the. So chapter 11, there are two portions actually within it. One is for the beams, another one is for the frames. So for all three cases we will be discussing actually. The third one you may keep it for the rest, but the two cases we have discussed. One is continuous span beam, and one is for continuous frame. If we say that no sway case frame. So for beams, continuous beams, and no sway case frames. So you have to solve two examples of each. On your assignment register. Is it clear to you not?
Yes, sir. Clear.
You need to solve 4 questions of deflection method from R.C. Hibbeler book. It's your assignment number 3, I think. So please go through it and solve it and keep it with you on your assignment register. Because once you will come to the final exam, I think you will bring this register to the university. समझ आई है जी कि नहीं क्या करना है आप लोगों ने?
Yes, sir. Agi.
Yes, sir, Agi.
Okay, then thank you very much. You can leave the chat room. This is all for my
Thank
side.
you, sir.
Thank you, sir.
Okay.